Earth-like planet discovered by NASA. The American Kepler Space Telescope has detected an exoplanet orbiting a star of the same type as our Sun. Another Earth. NASA had been able to find the words to draw attention to the press conference, call it organized on Thursday, July 23, on the latest results from its Kepler Space Telescope, which specializes in hunting for exoplanets, these planets located in other solar systems than ours. The American Space Agency has fulfilled the expectations of lovers of astronomy. A new planet of a size close to the Earth has been detected by the satellite for the first time in the habitable zone around a star of the same type than our Sun, but 1,400 light-years away. Named Kepler 452b, it brings the number of confirmed exoplanets to 1,030, says NASA, whose Deputy Director, John Grunsfeld, said its detection took us one step closer to Earth 2.0. With a diameter 60% larger than the Earth, Kepler 452b circles its star in 385 days and is 5% farther from it than we are from the Sun. It is therefore right in the habitable zone, the one where liquid water, essential to life, would be likely to be present. Kepler 452's star, known as 2MASS, is 6 billion years old, 1.5 billion older than our star, and also 20% brighter and 10% larger. These results will be submitted to the Astrophysical Journal. A substantial opportunity for life to emerge. It strikes the imagination to think that this planet has spent 6 billion years in the habitable zone, longer than Earth, says John Jenkins, chief of Kepler data analysis at NASA. This is a substantial opportunity for life to emerge if all the ingredients and conditions necessary for life existed on this planet. However, it is far too early to tell. Kepler is not able to determine the mass of the new planet, an essential parameter to know its nature. Rocky, gaseous, or a combination of the two, and to know if it shelters an atmosphere, underlines the astrophysicist in Marie-Lagrange Brennable Observatory. The researcher, who was not associated with the discovery, welcomes it because it shows that we can detect very weak signals over periods which correspond to that of the Earth. A large number of super-Earths had in fact already been identified, but in orbits much closer to the stars, where their radiation would have every chance of nipping any biological activity in the bud. Didier Queloz, Cambridge University, co-discoverer in 1995 of the first exoplanet, a super Jupiter, also highlights the progress made over the past 20 years. Today we're talking about a cousin of the Earth, even if we are not sure of its mass, he said. This is just the start of a very long journey. We will soon be able to have access to information on the composition of the atmosphere. It's not science fiction. This isn't the first time Kepler has claimed to have found a new Earth. In April 2014, Alyssa Quintana, NASA Ames Research Center, SETI Institute, and her colleagues presented in Science Kepler 186f, a planet barely larger than ours, but in orbit around a red dwarf located in the constellation Cygnus, 500 light-years away. A red dwarf is a star with lower luminosity and smaller in size than our Sun. However, Kepler 186f had the advantage of being in the habitable zone, at a good distance to shelter water in the liquid state. But as for Kepler 452b, it was impossible to know what was its mass, its exact composition, and even less if it had an atmosphere conducive to the chemical reactions which, on Earth, led to the emergence of life. Kepler won't be able to tell. The first instrument entirely devoted to exoplanets, launched in 2009, is now a living dead. The loss of gyroscopes no longer allows it to carry out precise monitoring of the portion of sky assigned to it. If the catalog he has established is a gold mine, to go further, it will be necessary to combine a whole series of instruments and detection techniques in orbit and on the ground. Warns Stéphane Udry, University of Geneva. Like Plato, a European Space Agency space telescope, due to fly in 2024, or small space telescopes that will focus on a single star, and spectrograph successors like CARPS from the European Southern Observatory. There is no shortage of ideas for detecting exoplanets, but two methods stand out. In 1995, the first exoplanet was discovered around a solar-type star by Mitchell Mayer and Didier Queloz, then at the Geneva Observatory, using the radial velocity method. This consists in measuring the color variations of the star induced by the movement of the planet around it. This dance modifies the location of the star around their common center of gravity. Like the sound of a fire truck siren, higher as it approaches, lower as it moves away, these periodic movements, relative to an outside observer, change the perception of the wavelength of the light emitted by the star. This is called the Doppler-Fizeau effect. Kepler uses the so-called transit technique, which consists of detecting variations in the luminosity of a star during the passage of a planet in the line of sight of the observer. It makes it possible to deduce the size of the planet and its distance from the star, in order to know if it is in the habitable zone, that is to say at a distance which makes possible the presence of liquid water, but does not reveal the mass, so crucial. Future advancements in other land hunting will come from the combination of these techniques. Because it is not yet a question of observing these stars directly in visible light, apart from the largest gas giants, which are 10 to 20 times the mass of Jupiter. The light they reflect is lost in that emitted by their star, or else too faint to be detected. This is also the case of the Earth, which hypothetical extraterrestrials would try to see from Kepler 452b. The pale glow reflected by our blue marble is drowned in the lighthouse a billion times brighter than the sun. Will we one day be able to explore more directly these systems that are cousins of ours? The length of the journey is an insurmountable obstacle. By way of comparison, the New Horizons probe, the machine which holds the speed record at launch, at nearly 60,000 km per hour, took 9.5 years to reach Pluto, currently 4.7 billion kilometers from Earth on the fringes of the solar system. Kepler 452b is 2.8 million times further away. And assuming that an intelligent being is ready to pick up a radio signal, it would take nearly 3,000 years for its possible response to reach us. Kepler 452b is a super-Earth-like exoplanet discovered using the Kepler Space Telescope. The planet, with a radius 60% larger than that of Earth, orbits in 385 days around its star, Kepler 452, located about 1,400 light-years from Earth, in the constellation Cygnus. The planet is in the habitable zone of its star, at a distance 5% greater from the latter than the Earth is from the Sun. The discovery of Kepler 452b, the existence of which has been confirmed by ground measurements, is announced by NASA on July 23, 2015, along with 11 other candidate planets of less than 2 Earth radii, also orbiting in the habitable zone of their star. Kepler 452b could be the first telluric planet detected in the habitable zone of a solar-like star other than the Sun itself, and can thus be considered as analogous to Earth, despite its volume 4 times greater. Until this discovery, telluric exoplanets orbiting in the habitable zone have been detected around stars fainter and cooler than the Sun. If you like the video, please don't forget to like and subscribe.